Okay, now we're ready to introduce the T Spline. So I'm going to go right to the actual definition. It's in Revit. It's already in the base level of Dynamo. And it's important to note that this T Spline, this whole functionality has been brought in from, I believe it is Fusion, one of their other Autodesk products. They had the functionality available. They thought to bring it into here because of all its usefulness, but there is some rough edges to its implementation at this point. Anyway, we're looking for a T-spline function that is surface to build pipes. So let's find a surface and then build pipes. And I've done this definition the year before, and they changed the definition as far as what the inputs are. So this kind of updates itself on its own, especially since it's at the base level of Dynamo. So any upgrade will mean that it could change. And the one that I had before this year is now rendered, I don't know what that, depreciated they refer to it as. So I had to replace it. So we need to put some input values in here. We need a couple of numbers. So I'm going to type in get a number function up. And I'll duplicate that. We need two numbers. This is what I'm trying to do is configure this so that it has the base level of elements, and then you can decide from there if you wanted to add more. And I need a Boolean operator, so I'll copy this one and paste it. And this will be true. We want this idea of, let me zoom in here, I'm sorry for that, so that it shows better in smooth mode. I'm going to start out with two values that I found successful. So I'm going to put 0.3 in for our default radius, and 1 for our segment count. And I really don't know exactly what all of these functions do. They're brought in, like I said, from another functional application. So there's a lot to be explored if you were so inclined to do that. So let's try to put these curves in. And like I said, we're going to get that warning now because this list is probably, well, let's make sure it's flattened, but it's just a poly curve. And it doesn't want to accept that. So we need the geometry explode function, I guess, for sure. I don't see why that isn't showing up better. So we'll plug the geometry in and plug that into the list. And now it's a happy camper. And you can see in the background that we have our T-spline surface generated. So now all we've got to do is pull this into our document, our Revit. We still don't have anything in here except for the mapping of the surface is a build pipes thing. But as a tip, before you actually do the generation of the T-splines, you may want to think about manipulating these forms until it gives you some kind of an arrangement that you're happy with as far as the way it's divided off. So let's go back to Dynamo now. And what I'd like to do is, I'm just looking at my reference document right now. And let's try to plug, this is a geometry that I thought should work with direct shape by geometry. So let's get this set up first. This is how we're going to export it, obviously, into Revit, send some kind of geometry. And we need a category, so I'll type in, look for category. And we'll just give it a generic model. And we need a material. And so we need a material by name. And this is always a little bit, there we go, it comes up as the first one. Oops, nope. it's material by name, so this is the wrong one. I'm getting a string out of it. I'm taking a material and making it into a string. So I'm going to have to type that in again. Material, oops. And then dot by name. And you'll see that's different looking. And we'll plug that material in, but we need a string value. In my case with this project, I've already made a color I call gray, closer to white really, but you can make up a material, and or there's a default, always just use glass, because that's always in the Revit package. So if you type in glass, it'll accept that. I think you might need a capital G. So let's just see, you know, we have a T-spline surface, and if we plug this directly in, it errors out. So we need some other kind of function for the conversion of the T-spline to something else. And let me close this off. And I'm looking for a solid function here. I'd used it before. I'm not finding it. So the function that we will use is to decompose the faces. So we're going to go to T-spline typology, and we're going to use decomposed faces. And what happens is now we get individual, all of this becomes a hollowed out object with facets on the face of it, which is a little more complicated than I would want to do. And but there's still geometry that this command can easily use. We might need to flatten that. Yes, we do. And you know, that might be, I'm going to just go ahead. No, that is already a flattened surface because there's only one typology. So I need to flatten that. And it's still not happy with that. So, and I kind of knew that. I was just kind of playing around with trying to get to the output here. If I look at the list of this, it's still a T-spline, and we really want it to be a surface. So I'm going to change that face into a surface. And I'm not sure what the where I grabbed this from. Face.surface and geometry. So the input is a face and out comes a surface. And I don't even know if we need a list flatten. Let me put, because it'll be a list of lists, but might not be critical. But you'll notice now that we're spinning around our wheels, so it takes a lot more computational time to do this actual conversion. And this is where I'd really like to figure out a way to remove a bottleneck, so to speak. And we'll plug that into the geometry. And it should go gray for us once it's finished running it. So give that a second to run. See if I can bounce back to Revit itself. No, I'm not sure how long this is going to, oops, I think it just completed that. So let's just go back now, and there we have our geometry on our building. So we've really completed the basic task. Let me go ahead and hide the mass element. And it's asking us to save the project first. Now I'm rendering this without any hidden lines, or without any lines in the showing in the renderings. If you use lines, because these are such complicated surfaces that are getting pushed out, the object will just appear basically black. So we have still spinning around trying to get rid of the and this conceptual mass disappearing. I find that switches back and forth in a relatively peculiar way. So sometimes it doesn't update that the mass is no longer there. Here's a view where the mass isn't showing. All right, so I'm going to experiment a little bit with looking at whether we can find a little more efficient way of writing this code. Anyway, the next time I pick up the video, I'll either have that or we'll move on to making a presentation sheet for this project.